So, how the spider simulator is getting linked? How the spider this console is getting linked to the simulator?
Okay, yeah. Let me just stop this. Okay, so there are basically two things that you need to do. One is this particular command right here. So there are two things that you need to do. One is you have to open up a communication channel between Python and Spider. And
Okay.
the second thing is you have to start communicating. So this is like a basic principle in the Internet of Things. You have to open up a port, and then you have to, so that once that channel is open, then you can start communicating. Now, to do the first step, right, to open up the communication channel, you remember that I ran this command right here.
Yes.
If you want, I can. I'll just show that to you again, so you can see what's happening. Okay, so when you start a new scene, right, what you have to do is you have to go to any of the scripts here and then go to the top function. You can basically copy this command anywhere, actually. You first have to copy this command right here, this simex right here, simext remote API start, and just paste it right here. So what this single command does is it opens up a communication channel on this port, 19,999. Once you do that, you then have to, in your Python script, you have to call these lines of code. Import sim lines 1, 4, and 5. So once you've opened up the channel, you have to start, sending information between them. You have to make sure that the number that you used in VREP is the same number that you used here. Yep. So this is the function right here. Start. Yeah, this is basically the function right here. You can have a look at this remote API link. I'll attach this link also. So yeah, does that answer your question?
Yeah, it answers, sir. Thank you.
Okay, yeah.
Yeah.
I had a question. What if the obstacle is also moving? So how does it like project, like where it's going to be after a certain period of time, and how to avoid?
Yeah, that's actually a good question. So you'll have to have more complex algorithms for that. You can right now you can create like a simple rules-based sort of thing, but like if you're actually writing an obstacle avoidance algorithm for like a moving robot, right? Things might get a little bit messy because you have to also be able to predict the motion of the obstacle. It's not just being able to sense the obstacle, right? You need to be able to predict somewhat how that obstacle will move. So to do that, like in a very complicated manner, which is what self-driving cars do, you might have to use maybe like machine learning techniques. Maybe like you have to use RNNs for that, because they are well suited for that sequential sort of motion, or planning of motion rather. Yeah, for this lesson, you don't have to worry about moving obstacles, but yeah. So once you get these two pictures out of the way, right? Once you're able to move the robot, once you're able to see an obstacle, we can move on to the next lesson, which is basically, have a line follower implementation. And with these sort of things in our once we've done these sort of things, you can then move on to your first actual robotics module, which is like an obstacle avoidance implementation. So that is like the simplest module in robotics. Yeah.
Yes, thank you everyone for out and does the exercise that Sharat just showed you, because there's nothing like doing things hands-on, which is why we are going with this kind of a project-based approach, so that people don't have to get bored, just they can actually try out things for themselves and see, because that's how real engineers and scientists work, right? So we hope that you get your hands on and you know uh, do all the exercises that Sharat has been asking you. Thank you.
Yeah. So if you have any questions, you can always just ask in the group. Yeah.
Thanks, Sharat. Thanks, everybody.
Yep.